I will be talking today about the ISO SAE 21434. This standard is already published, and I was involved in the preparation as the country coordinator for the Austrian expert group, and ISO PAS 5112. There I was the overall project lead, and the first draft for publication was submitted this week to ISO. So this already published. This we expect the publication beginning of next year. And I will present both of the standards. I will try to not only present the standards, but also explain a little bit the logic in the development behind them. Because if you read such a standard, then it's always difficult to understand why things are done in a certain way. And often this is due to discussion and due to points raised during the development. And if there is at any point a step or content where you think, hey, that could be interesting, or I would like to know more about that, please interrupt me. Then we can discuss this. I tried with the slides to keep them in a level of numbers of slides that we have some time for such questions. And hopefully, if it's then also interesting for your work. I will start with a short motivation. So, what are we talking about? What is automotive cybersecurity? Why are we talking about it? Then an overview, how this relates to the overall automotive safety and security related standardization landscape. And then I will go into the two standards itself. If you talk about automotive and security, we have at the one time quite a long history. But on the other side, for cybersecurity, it's not that long. So the first thing which was done in cars was that there was a lock which stopped the electric circuit. So this was still the time when you had to wind up your cars. There was no electric starter, but you could lock this starter circuit. And then after that, there were the keys for the car door, the first keys for the ignition, and then 1986, we see the first electrical component. And we can talk from vehicular security to vehicular EE security. There was basically a resistor in this key, and this resistor had a value, and the car knew the value and checked it, and only if this matched, the car opened up. And from then, the evolution was quite fast. So we had keyless entry, we had remote start and could control some features. And there we can begin to talk about vehicular cybersecurity. We have then the introduction that you no longer have a car key, but your smartphone has an app and can control, steer, and open the car. So you can even now with the smartphone, the car can automatically move out of a parking place without you being in the car. You simply start this in the app. And now with 2020, we have the first serious vehicle with car-to-X communication. And we have the first countries. So in Austria, the ASFINAG is building up the complete highways with car-to-X infrastructure. And this means that in the past, the main concern we had when we talked about vehicular security was vehicle theft, because this could happen. And now we have the connectivity, we have the data on the vehicle, and we have to think about the safety that someone is manipulating our car, the operation of the car. You have for some remote features, for multimedia, you can charge or you can pay for films in the car. You have your credit card information stored in the car, and there could be a financial damage. If someone stops the car, then you have an operational issue. And with all the location data stored in the car and everything our cars know about ourselves, we also have the privacy issue. And obviously, all of these 4 points, they are from the viewpoint of the user of the vehicle. But if you talk about not only the user of the vehicle, but also about the producer, about the supplier, about the OEM, they obviously have also the theft of intellectual property. So control software, SU software is not easy to develop. If you talk about automated driving, the algorithms for detections, the trained networks, this is all quite valuable. And there we always have to consider these two different viewpoints, stakeholder, obviously. Our first thing is we have to protect the road user. There is on the one side a legal obligation, but also from a business point of view, if you kill your user, he will not buy a second car. But also we have to protect the information, the value we put in the vehicle. For privacy, there's one important thing. So privacy, there is a difference between the technical aspect, meaning how can we protect personally identifiable data. This is anonymization, this is encryption, these are technical measures, and this is something I will talk about today. This is included. And then there's also the lawful basis for data collection. So in Europe, we have the GDPR, General Data Protection Regulation, and there it's defined what has to be done to get the consent of someone that you are allowed to collect this data. And these are not technical issues, these are legal issues. And these legal issues I will not talk about. I'm not a legal expert. And please only be aware, different nations, different regions have different regulation on which basis you're allowed to collect data. And this is something which has to be considered. But these are the two different aspects of privacy. This one is technical, this one is legal. And so far, we've seen that there is the rise in connectivity, that there is a rise in risks. And this alone would not be that dramatical. This alone would be like, okay, good, maybe we have to do something, maybe there will be an issue. But the problem is we have also on the same side an awareness of attacker and a quite high rise in attacks, especially in remote attacks. So meaning no longer an attacker which is standing beside the vehicle, but really someone who is sitting somewhere on the internet, on a Wi-Fi, and attacking the vehicle via these channels. And why is this? Because we have vulnerable architectures. The inside of a vehicle, there is technology used which was developed 20 years ago, and there was no thought spent on that this is connected to the outside, that this is interfaced with the internet. But we have the increasing connectivity, which means our vulnerable architectures are only one gateway, one firewall away from the internet. And we had in the past standards and regulations without security. So to bring a vehicle in the market, you had to check that the brakes are working. You had to check that the lights are working. You had to check the size of the mirrors. You have not to think about the cybersecurity of it. And therefore, cybersecurity was more afterthought, not a focus. But this is changing quite rapidly. So this is now only from 2020. In India, over 4,000 vehicles were stolen with electronic devices. They could bypass the engine control module. They hacked the ADAS system of Tesla. There were vulnerabilities in Mercedes. This one, the April, this is interesting because basically what you have to think about, if you bring a vehicle in the market and this vehicle is connected to the OEM side, this is more or less entry point for an attacker which they completely control. So they took this opportunity and reversed TCU. This is the telematic control unit, the infotainment, entertainment, and connectivity unit, and used this connection to infiltrate the OEM corporate network. And then more vulnerabilities and more hacks. So This is really something where we say we see now what we are knowing from other domains where security is an issue for longer, where connectivity was established, that we are basically getting used to having each month one or two big things in security happening. And one of the issues here is that not only vehicle theft and that not only the attack on the OEM network, that on the other side, the control a vehicle has over its own system is rising. So we have automated driving, and there are already discussions and accidents. Overall, so far, the rating is there are a little bit more crashes, but the injuries are much smaller. But as soon as we combine these two, as soon as we start to combine the automated driving with the cybersecurity issues, we will have a real challenge, because that means basically that for a good hacker, he has his own toy car fleet, his own remote controlled toy car fleet on the street. And this is something we would not like to have and we would like to avoid. And this combination leads to quite a development evolution in the standardization landscape. So if you're aware of automotive and standards, all of you know the 26262. This is more or less the basic standard. This was published, the first edition, 2011, and it was a good standard. And then the technology evolved. We collected experience with the standard. And 2018, so after 7 years, we had the next one. And you already see here the timeline. The first step are 7 years, and then we have 1 year step. Because then we had the next year the first standard on automated driving, the SOTIF standard. And then we had a technical report and safety and cybersecurity for automated driving. And then we had the cybersecurity standard. And this is all the standards with their expected publication time, which are now in development. So we see there really an explosion of the automotive safety and security landscape. And this is triggered by automated driving and connectivity. Automotive AI, automated driving, predictive maintenance, connectivity. We collect data, we predict. Qualification of pre-existing software. This is also about partially automated driving. The whole cybersecurity, connectivity. SOTIF, this will go to a direct standard. Software update, without connectivity, there are no updates. With a self-learning automated system, there is a need for updates directly between connectivity and automated driving. And then also here, they're working on the next iteration. So there's really now, from the standardization landscape, a much faster pace, because the topics are increasing and the criticality of the topics is becoming much larger. So this standard, this was done because the automotive industry used the basic safety standard 61508, and then after a few years said, maybe we want to have here our own version of it. But there was no large need for it because they know what they do. And for cybersecurity, I said it before, there are no regulations so far, and this is changing, and this is a massive difference between the cybersecurity and the safety. Because, so this is now from the European Union, this is not global, this is only Europe and a few other nations, a new approach, how regulations and standard work together. So this regulation, 2018, is the type approval regulation. And it specifies that in order to get the vehicle type approved, it has to fulfill certain criteria. This was before mentioned, the brakes, the mirrors, and all of this stuff. And this is more or less stuff which was tested in, you take 5, 6 vehicles of the production, you test if they are working as specified, and then it's fine. And this is now extended from this classical type approval to cybersecurity. And this is a huge topic and will drive the uptake of automotive cybersecurity to a very, very large degree. Because basically, what has happened, there's a regulation on automotive cybersecurity. This was mandatory made by the European law. And then there are standards which tells you how to implement this regulation. And this regulation was published in 2021. And we are now in the transition period where this regulation is not yet fully mandatory, but parts of it are becoming mandatory. And in 2024, it is completely mandatory. And for an automotive development, 2024 is not that far away. And this is one of the reasons why we see now this huge drive in automotive cybersecurity, why there is that much of an interest, because if you try to bring a new vehicle type on the market after 2024, this vehicle has to be cyber secure. And how to argue the cybersecurity on a whole vehicle level, this is something which is currently in very strong discussion and elaboration, because this is not something which was done so far. If you look at other standards, for example, the common criteria with the emulation assurance criteria, they are working on chip cards. But on the complexity of a whole vehicle, this is really something which is quite challenging, quite new. And there are also others. So this approach in general, there's now also a regulation on software updates and one on automated lane keeping system. And all of this works in a similar way, that there's a regulation which is mandatory, and then there are standards which are recommended to implement this regulation. And I said before, this is mainly Europe, but a few other nations also. So all green marked nations, all of this follow this UNR 155. And in all of this green marked nation, if you want to sell a vehicle after 2024, it has to be cyber secure. And not only this, what you need is you need a cybersecurity management system, which covers the whole life cycle, which manages the cybersecurity. You need to maintain this compliance with the CSMM through the vehicle life cycle. You need to update the cybersecurity, and you need also to involve your suppliers. So basically, you need to show that your cybersecurity management system covers your suppliers and service providers. And this transfers the obligation for cybersecurity from only the vehicle manufacturer also to the supplier. And so this is now the timeline. As I said, 1st July 2024. After that, there has to be a CSMS before the vehicle manufacturer is allowed to demonstrate that cybersecurity was achieved without a CSMS. But still, this is quite challenging. There's not that much time. And in order to go from this regulation, which is rather high level, to something which can be really implemented and done on a technical level, the automotive domain developed this ISO SAE 21434 road vehicles cybersecurity engineering standard. A little bit to the history. So the first thing what was done for cybersecurity in automotive standard-like was from the SAE. This was the Cybersecurity Guidebook, which was published in 2016. And this was more or less not a standard, but a collection of guidance from research projects, from open source, from other domains, what could be done for cybersecurity and how it might be applicable to the automotive domain. And based on this first document, ISO and SAE started development of a cybersecurity engineering standard. And in the beginning, the focus was really on cybersecurity engineering. Halfway through the development, So 2016, it was started after the SAE published their guidebook, and 2018, 2019, the first draft of the UN regulation became applicable. And this led to a change in the standard itself because it moved from a purely engineering standard to a standard which was developed to be in compliance and to give guidance on how this regulation could be implemented. And there were a number of experts are active in both in the development of the ISO SAE 21434 and in the UN regulation. And therefore, we achieved there quite a good overlap and compliance. But it definitely shifted the scope of the standard a little bit because it moved from an engineering standard, how to develop cybersecurity, to a more or stronger focus on cybersecurity management and on covering the topics which are required by the regulation. And overall, some parts in the standard are, if you go to the standard, um, some parts of the standard are more in annexes. So there's a large list of annexes below this overview of the main chapters. And topics were done in annexes. For example, there is a similar concept to the safety integrity level, but for cybersecurity, the CAL. And this is only done in an annex and only done informative. And this was done because all experts said that could be interesting, but on the same side, no expert already used it. So there was no knowledge if this really works, if this is really something which can be done in practice. And therefore, it was decided to put it as informative in order to allow the industry to collect some experience with it. And if it works good, it can be done as a normative part. But if it's not working, we can always remove it. And this was really done here for many parts that we said, okay, good, this sounds like a cool idea. And if we think about it on the scale of a small example, it seems to be working. But does this work on the level of a complete vehicle for 100 projects? And if we had there not a clear yes, we moved it to informative. Um, Always considering this relation between the standard and the regulation, because we knew that the regulation refers to the standard. And so if we say this is required in the standard, then this is not only recommended as state of the art, but this is really then referred from a regulation side and therefore quite mandatory. So if you ever go through the standard and are irritated why some topics are only as informative there, this is the reason for it. We were not sure if they will work, and therefore we put them as informative. And if you ever use something from the informative part and it works well, please give me a short email or a note. And if it does not work well, do the same, because then we collect the experience for the rework of this, which was also already started. From the content itself, we have the organizational level, which is on the organizational cybersecurity policies, rules, processes. We have the project-dependent cybersecurity management, which is on the management and cybersecurity activities at the project level. Then we have the continual, and this is now here a little bit important, why we have these three levels. Organizational is everything what you're doing to prepare an organization for a cybersecurity project. So these are the policies, the strategies, the rules, the processes, and you can do them without having any cybersecurity project. You can do them purely as a preparation for a project. And if you have a project, you have the project dependent cybersecurity management. This is then how you do cybersecurity on a project level. And there are some topics which are not only for one project, but for all projects. But at the same time, they are not making sense without a project. And this is vulnerability management, incident handling. You will not handle incidents if you have no cybersecurity project, but you will also not handle incidents on a project dependent level, but rather on a overall level for all projects. And therefore, this continual cybersecurity activities collect all the activities which are on this level. Only necessary if you have projects, but not necessary for one specific project, but for all of them. Distributed cybersecurity is how you can distribute the cybersecurity activities through the supply chain, so the interaction between OEM suppliers, between suppliers of different tier levels. Then we have the classical engineering lifecycle phases from concept, where we identify the cybersecurity risk and cybersecurity goals, to the product development, where we have the cybersecurity specification, implementation, verification, validation, to the post-development, where we have the manufacturing, assembly, incident response, updates, end of support, decommissioning. Here it's important. So there's a stronger focus on the manufacturing than for the safety standards. Because if you have some end of line tests, if you have some key material introduced during production, these are all potential attack surfaces, all potential attack points, and this need to be protected. And therefore, there is some focus on what standard could be used to protect your production environment. And then we have a sort of a toolbox-like approach where we have methods for cybersecurity risk analysis and assessment, which can be used for the overall analysis, which can be used for identifying the risks, the goals, and which are there more or less on a introduced in a way that they can be combined and used on different levels of granularity. And if you want to talk about these risks and these goals and how they can be derived and how this can be done, and what are the different work products and things considered for such a threat analysis and risk assessment, we need to talk a little bit about terminology. And I try to keep this short and I try to keep it interesting. But we should try to have here understanding of what are we speaking about. The first thing is, what do we protect? And there we have the item. And this is one point where we had very long discussions, because the cybersecurity item is not the same as the safety item. So the cybersecurity item can have a different scope than the safety item. And therefore, we were not quite sure if we should call it item or something else. In the end, we decided on item and made a note that the item definition from the 21434 is different than the item definition from the 26262. I personally do not like that it's called the same and defined differently, but it is like it is. An item can have an asset. An asset is anything which has a value, either to the vehicle user or to the society or to the OEM or to the supplier. Basically, an asset is anything you want to protect. And you don't want to protect this asset completely, but you want to protect certain cybersecurity properties of it. So for example, if you stored your credit card information in your car, you would probably like to protect it against stealing this information, so the confidentiality of this information. The protection against deletion, this is not that relevant, because if somebody is able to delete it, this is not great, but it's not as worse or not as risky as if someone is able to read it out. And if someone is able to modify or to violate this cybersecurity property, then there's a damage scenario. So if the asset is the credit card information or the brake of the vehicle, and someone is able to either steal this information or manipulate the braking, there's a certain damage caused by this. And this is what we want to protect. We want to protect the assets, cybersecurity properties, so that no damage scenarios are caused. And we want to protect it against threats. Threats, we have again our item, and then we have the components. And these components might have some weaknesses. And these weaknesses enable some threat scenarios. And if you have enough weaknesses in threat scenarios, there's an attack path. And this threat scenario is then able to realize such a damage scenario. And in order to prevent this, you define cybersecurity goals. And these cybersecurity goals are broken down and realized in cybersecurity requirements, which are allocated to the components. And this is connected to the threat identification. So for the asset identification, for the attack easiness, for the attack path analysis, you can do a threat identification. And threat identification, threat modeling is basically something very simple, and it can also be done manually, but based on the complexity of the system, I would not recommend it to do it manually. But basically what is done is it's a sort of structured process. You're looking at something and you're thinking from the perspective of an attacker, what could the attacker do against it? Wooden castle, fire. And then you try to update your system so that these weaknesses are resolved. If the enemy has fire, you use stone. And the problem with security, the issue is that the other side, the attacker, is also updating. If you use stone, they use guns, cannons. And therefore this process needs to be repeated, and the capabilities of the attacker need to be considered and need to be updated. If we go here to an automotive point of view, then we have our ECU. We have the function. This is basically ECU, which has remote connectivity for the onboard network, which has a human machine interface. And we can say that for the analysis itself, we have to consider this whole system, because there, this connection from this gateway ECU to the rest of the CAN bus to other ECUs, if an attacker would be able to use this, there might be some damage scenario, and we have to consider this backend because there's an interface, there's a connectivity, which could be also used. But we have to be aware of what we are really developing and what we have to consider in the analysis. So we have our thing, what we're developing. We have the components in the vehicle and in the backend, and we have this overall system, what we have to consider. And here we can do something. Here we can place security measures. For the rest, we can consider them in the analysis. We can check what security measures are already defined there, but we might not be able to modify them. And then we have to identify the interfaces, what they can do, We have to identify the system properties, what is already there on security. We have to identify our assets. So there are different viewpoints from different stakeholders. So for example, if I'm talking about the user, then the asset from their side might be the scan interface, because if an attacker is able to manipulate this, he might cause a potential safety impact. If I talk about the producer, he might think about the IPR, about the software in this gateway. And in general, the standard gives here a list of things which has to be considered for such an asset. So as I said before, we don't want to protect the asset overall in its totality, but there are some cybersecurity attributes. And all of these lists are given as minimum required lists. So these attributes I have to check if they are relevant for an asset. I can also introduce here additional assets. So there's, beside this CIA, there's also confidentiality, integrity, availability, and authenticity, and even more complex sets of cybersecurity attributes known. And I have to consider at least these three, but I can consider always more. For the impact categories, safety, financial, operational, privacy, the same. This is the one I have to consider. I can consider more. And then the impact levels. So it's recommended to use 4 levels. And the impact is rated here. If we go to safety, then for these 4 levels, simply the severity levels from the 26262 are used. For other properties, so if we talk about financial, then there is a scale contained as informative, but also the remark that different scales can be used. And this is allowing us to answer, what do we need to protect? If we are not able to protect it, what will be impacted, and how bad will the impact be?
Christoph, just a short question. Hello?
Yeah, sure.
Yeah, the ratio between the attribute and the category, impact category, is a 1:n, or is it a 1:1 always?
No, it's a 1:n. So I can have, I mean, for confidentiality safety, it's difficult, but I can have an asset which has, where I want to protect all 3 attributes, and then all 3 attributes can have an impact in all 4 categories.
Yeah, okay, thank you.
You're welcome. As I said, if there are any questions, please always ask. This is, then it's more interesting for all of us. As I said, for the producer, if they are asking this question, they might have here completely different assets. It's important to consider here all stakeholders, all viewpoints we have. So for the partners in the values project, we are working with Liba on here a tool for that, and this can be available for research. And we are happy to support you with this in the project itself. And this is basically implementing this threat analysis for the automotive domain. And you can model your system and model your assets and identify the risks and the attack paths. But this is only solving the issue from the system to the risks to the cybersecurity goals. If you talk about the full life cycle, basically this part from the concept to the beginning of the detailed design. And that means we need testing tools, we need secure coding guidelines, we need all this stuff on how to build up vehicle systems securely. And normally, at the higher level, so at the concept, the operation, integration, there's the role of the OEM, and at the lower level, there's the role of the suppliers. And this is challenging because in the end, the OEM wants to bring this vehicle to the market, and the OEM has to ensure and has to prove that this vehicle is secure. That means he has somehow to show that the security standard was used along the entire supply chain. And this picture is directly taken from the standard. The only modification from my side is here, this colored box. Because we see on the project level, on the cybersecurity assessment, there's details given what can be considered, the cybersecurity plan, the work product, the cybersecurity case. This gives us the arguments for the cybersecurity assessment. We can then judge that the objective are achieved by this item, and the provided arguments are convincing, and there's a step-by-step guide how this can be done. So this project level, this is more or less detailed. There's still a challenge to go from this item or component level to the vehicle level. But this is something which is discussed if this can be done compositionally or if this is how this can be done. But from the item or component level, the ISO SAE 21434 gives us a good guidance how we can assess the cybersecurity. How we can assess or how we can audit the management and the processes, there is not that much more than this box. Because in 547 is a short text that this has to be audited. And therefore, and especially with the knowledge that we have this UN regulation on cybersecurity, there was quite a struggle how this cybersecurity audit on the supply chain can be done. And for that, the ISO PAS 5112 was started. And the goal was here to provide a framework to verify the application of the ISO 14034 from contractors and suppliers. So usable on all levels of the supply chain. There's a exemplary question based on this 21434, which can be used during such an audit, can be used by suppliers independently or with assistance. It gives guidelines how an audit program can be managed, and it's based on a general standard for auditing a management system. So basically, it's more or less general standard extended towards auditing for an automotive cybersecurity management system. And the structure is more or less similar to the general audit standard. So they have this managing audit program, and always there's additional guidance given on what is specific for the automotive domain. Conducting an audit, the competencies and evaluation of auditors. So this was a very strong discussion point because from the automotive side and from the industrial side, there was a strong wish to have here good guidance because they said this topic is so new and so special, and auditors with a knowledge in cybersecurity and in automotive are on the one side very rare but needed. And we really want to define here what a person or a team who audits automotive cybersecurity management has to know. Because we don't want to have persons who simply come with a checklist and only check mark, but we want to have auditors who understand. There's this audit questionnaire. So example question evidence what can be asked. And then there's even an annex on what competences such an auditor should have. So this was really a strong focus point. And The goal here is to have a more or less seamless interaction from the regulation, where the OEMs have to comply with, where there's an interpretation document, which gives some additional guidance, where the ISO SAE 21434 is referred, how such a cybersecurity management and cybersecurity can be done, to finally the ISO PAST 5112 on auditing and a VDA document on CSMS. And while there is the OEM who's responsible on this side, he needs the supplier for argumentation. Because if a system, an item is built up by a supplier, then the OEM is not necessarily aware of all the steps and all the activities which were done for cybersecurity. And so there is this strong collaboration and trend towards we need cybersecurity engineering, we need it in the automotive domain, and we need it as fast as possible because, said before, 2024, you're not allowed to bring in a new vehicle type in the market which is not compliant with this. And this means that you need all of that. And therefore, this is the reason why there is now this huge topic and huge trend towards automotive cybersecurity, because for safety, there was much smaller pressure, because for safety, if accident happened, you had to show that you are compliant with the state of the art. But this could be done by also showing not necessarily 100% compliance with the 26262, but by doing stuff which is better or on a different level. And therefore, the uptake of the 26262, I think now it's more or less completely taken up, but this is now 10 years after the publication of the first version. So quite a long time. For the 21434, the industry has 3 years. Then it has to be not only taken up, but projects already have to be done based on this. And 3 years in automotive is not that much. If you want to develop a new vehicle, 3 years is not necessarily enough time to have the complete development and production. So it's a challenge on the one side, but since we are here from a research perspective, it's also a huge opportunity because, as I said, the standard does define the engineering, but it does not prescribe specific technologies, methods, approaches. And here to fill in this gap between the standard, which says what should be the result, and the concrete guidance, the methodology, the support in doing it, how this requirement from the standard can be done, can be implemented. I think this is a very interesting and important topic which needs to be addressed in research and where there is a real need from the industry to have this topic addressed and solved. Overall, to summarize it, it's interesting. Standards are, the first one is there, the next one is coming in a few months, but there's still many open questions on how this can be done.